What's going on, LinkedIn? Brian White here with Spenty's, and Spenty's invented the scan, model, print workflow for 3D printed upper extremity orthoses. And today I'm going to show you exactly what that workflow is in practice and how it's being used all across the world, from clinicians with minimal technical experience all the way to the experts who are doing 10 of these a day. And so without further ado, there's no fluff here. I'm just going to jump right into it. Follow along with me because I think that you'll be quite interested in this digital process if you're looking for efficiency, better patient care through providing advanced orthoses with lightweight, breathable, low-profile designs, and just using 3D printing in your clinical practice as a way to help patients better. So this scan has already been taken. A lot of our partners are using scanners like the iScan, or they'll use an iPhone scanner like Comb or Structure or SnugFit. But scanning has become extremely accessible. For less than $1,000, you could be able to have a handheld device, or you could download an app like Structure Capture in 2 days on your iPhone, subscribe for a $20 a month license, and be able to capture scans. There's a different range of scanners in regard to quality and accuracy, but if you'd like more guidance on scanning, happy to give it to you. But we're scanner agnostic, so we've imported an STL, that's the file format of 3D scans, into our software, and I'm now going to drive the process. So Spenty's is a digital workflow that focuses on simplicity and accessibility. We believe that 3D technology is the future of clinical care, but we also believe that traditional CAD tools, computer-aided design tools, are complex and hard to navigate. So you'll see in our UI our philosophy. It's very streamlined, it's straightforward, there's not a lot of options to choose from, and that's on purpose because we think that you are best suited focused on the patient and not on the 50 million options that you can do in CAD. We know that when you come to Forma, your job is to create a custom upper extremity orthosis for this application, and that's all that you're there to do. So you need to get in, get out with the amount of quality and control necessary to create the design. So what I did initially was an initial cleanup. Now we're going to change the position of the joints. This is an optional task that you can do in Forma, and the workflow will guide you to place landmarks on specific anatomical points, so that what we're really doing at this point is giving vision to Forma. You as a clinician and practitioner get to scan the patient and then get to annotate the scan so that the engine, the 3D automation, I know I'm using a lot of buzzwords here, but and it's one of my challenges. I need to be more straightforward. What we're doing is giving vision to Forma so that the software knows where these anatomical points are so that you can be able to efficiently and quickly make corrections to the patient's position. So after placing those landmarks, I can select on the joint and make the anatomical changes. See here we're with the thumb and we're able to flex and extend the thumb. I can come to the CMC and abduct it, making these changes pretty straightforward and pretty easily, opening up that web space. Or if you really wanted to, let's get this scan. Adjust this add an adduction of the wrist, you can do so too to get to a more neutral position if that's your objective. Okay, so we've made these changes and we'll move on to some smoothing. Or if you're going to be immobilizing the thumb, you can do that as well with a thumb correction. Let's just create orthosis where the thumb is free now, and I'm just going to do a general smoothing to make the internal surface of the orthosis as smooth as it could be, because we see that there's some pixelation done with the scan. Okay, so I make this general smooth, and this blue area is bringing the surface to one consistent thickness, essentially. Not thickness, but smoothness. See here. Now we have a nice smooth surface. And that is it for the cleanup stage. Now, the last part of the digital workflow in Forma is either auto Forma or free Forma. I'll start by showing you free Forma because it's we brought sculpting to the therapeutic world. And it's where you could be able to draw the orthosis onto the limb using really simple and easy to use sculpting tools. So this is more for some of the more complex cases. We see that you may need to avoid pins or scars or bruises. You could be able to make those changes to the actual design of the orthosis really easily. So you just draw it onto the limb. And again, this is kind of a fast example because I want to capture your interest here on LinkedIn. And so that maybe we could be able to book a more live demo with a patient case that you have. I'm happy to always do that. But for this example, we don't really focus too much on the edges because we've got some advanced smoothing that takes place. Just press next step. And we will adjust the global thickness to maybe 2 millimeters and then increase the thickness in the wrist, just maybe in this region to 3.5. Just as an example. I mean, this is one of the core benefits of additive manufacturing is that you can have variable wall thickness in a single plastic device. And you can do so really easily. So if you want to have various zones of thickness, you can do so, as you see here. Let's do a little flare on the edges. Cool. It's automatically done for you. And then you could wrap things up by adding closing systems. So we have rivet holes, pins, belt loops, slotted hole. You just place the node onto the scan, and then you can adjust, and then it'll automatically add that closing system for you. So this is free Forma. It's the ability to design anything from scratch. But we also have auto Forma. So I'm going to jump back and go to auto Forma. And auto Forma is for the clinician that has the freedom to go fast. And it's going to use the same landmarks that we've already placed and generate a template onto your patient's custom scan. Then you could be able to manipulate the trim lines, the openings, the thicknesses, as you would for any other custom device. So this wristband orthosis is populated on the patient's custom scan. Let's maybe adjust the length a little bit. Bring this trim line more dorsally, whatever you'd like to do. And then if you'd like to adjust these openings and make them wider, it's a really simple and straightforward process. Okay. Now from here, you have the capability of, again, adding some flare, offset, thickness adjustments. These are the same tools that our partners at Mayo Clinic are using and having great success in their patient care and all over the world, in the Netherlands, Belgium, UK. The ability to take a scan and then import it into Forma and quickly generate a patient's custom design is proving to be quite powerful. Actually, let's select all and make them all a little bit less than an inch strap. Okay. And now from here, that since we've designed the orthosis, you can see it's much more faster than Freeforma, but it's a different design. We bake in the template, but you could be able to validate the design, save and exit, and send to your 3D printer on site or print with Spenties if you prefer, and have a custom-made device from 3D scanning completed really efficiently. If you'd like a deeper demo of the Spenty software, or maybe diving into our lower extremity applications or prosthetic applications, whatever it is that is mainly triggering you to find the value of digital technology within your organization, please reach out. Happy to dive in together, and we'll go from there. All right, take care wherever you are in the world.